I'm on the footpad in Houston. I step off at the surface at Taurus Littrow. We'd like to dedicate the first steps of Apollo 17 to all those who made it possible.
My brother and I went to a Smithsonian Space Museum in Kansas as a guest of the facility. And at the end of it, they had a shop that had a couple of these spacesuits in there. They're replica spacesuits, and they've been signed by astronauts. So there was one that was signed by Buzz Aldrin, who was the second man on the moon. And the other one was signed by Eugene Cernan, who was the last man on the moon.
I come out here. Oh my golly. Unbelievable. Unbelievable, but is it bright in the sun?
So, Buzz Aldrin's the famous guy. I went for that and they said, don't take that. Buzz Aldrin signs everything. Eugene Cernan hardly signs anything.
Okay. We landed in a very shallow depression. Very shallow dinner plate like this crater, just about the width of the strut.
And then if you think about it, historically the first man on the moon was fantastic, but this guy was the last man on the moon.
This is Gene and I'm on the surface. And as I take man's last step from the surface, back home, for some time to come, but we believe not too long into the future.
It's almost tragic, it was 40 years ago, and he even, if you read a book about him or read about him, he even, as he stepped back into the capsule, said, we came in peace, may we come back again soon. Because at the time he knew that was the last flight, and he said, may we come back again soon, and we haven't.
We leave as we came, and God willing, as we shall return, with peace and in hope for all mankind.
So I look at that and I get inspired that, I want to fulfill what he wanted humankind to do. We've got to get back to the moon.
I was strolling on the moon one day in the merry, merry month of December. No, May's the month. May, that's right. May is the year of the month.
Welcome to Moonshot, the show bringing you the latest and greatest technology that is about to change your future. I'm Christopher Lawson.
And I'm Andrew Moon.
And in the next 2 episodes of Moonshot, we're going back to space. Not literally, of course, but you're going to hear from some of the people making the space race more affordable and more accessible.
We're talking to some of a new breed of space companies who are trying to make it cheaper to build space technology. Things like satellites and, of course, rockets.
So join us as we explore the new era of space. And in this episode, we meet an entrepreneur taking on the giants of the space industry by building his own low-cost rockets. When you think about space and the companies building their business around what's out there, it's hard to go past the big players like SpaceX, Blue Origin, and even Virgin Galactic. Each of them has lofty goals of one day turning outer space into our new urban centres, sending masses of paying people beyond Earth's atmosphere. We know that Elon Musk wants to send people to Mars. We talked about that in our very first episode of Moonshot. But while all those big space companies have deep pockets which they're using to build huge rockets, there are many smaller startups trying to step in and fill the void. Welcome to the small space market.
We are designing and building a launch vehicle predominantly for launching small satellites into space.
That's the voice of Adam Gilmour. You heard him talking at the top of the show. He's the founder of Gilmour Space Technologies, a company that is actively trying to get in on the space race. by building their own small rockets.
So our rocket's going to be around 25 meters tall, and it's going to have a diameter of about 1.5 meters wide.
Gilmour Space manufactures their rockets out of a small warehouse at Pimpmar on Australia's Gold Coast. They also have an office in Singapore, and the market they're trying to capture is very different from the big players like SpaceX or Blue Origin.
Those guys are both going after kind of what I call the big end of town. So they're building massive rockets that can take payloads the size of 2 school buses into space. And they're hoping that their kind of technology can expand human exploration. So they're basically hoping that NASA and ESA and all the other space agencies give them contracts to send people and big payloads to the moon and Mars. The market we are looking at is the small satellite market. The small satellite market doesn't go well on a big rocket because a rocket only really goes to one place. And if you're a small satellite, you go where the big satellite goes, not where you want to go. So as the small satellite industry's grown, we've found that there's a desire to go on a small rocket that takes exactly where they want to go. And that's the market we're going after. So for example, in pure numbers, our rocket will be able to take 400 kilograms to orbit. When the Falcon Heavy goes up, it can take 54,000 kilograms to orbit. So very different kind of target market that we're going after.
Gilmour Space isn't the only company racing to build a big business out of small satellites. And before you ask what exactly small is when it comes to satellites, these things are defined as being anything up to 500 kilograms. Now, across the ditch, New Zealand-based Rocket Lab is another player. They're a couple of years ahead of Gilmour, and they recently launched a rocket called Still Testing.
5, 4, 3,
ignition.
Which had a small payload of cube satellites on board. These satellites are even smaller again, about the size of a single loaf of bread. In the United States, Texas-based Firefly Aerospace has taken in more than $20 million of funding. And not to be left out, Richard Branson's Virgin Group has launched Virgin Orbit.
We thought we could make it much more affordable for people to put small satellites into space.
Their aim is to launch small satellites from the wings of a Boeing 747 at 35,000 feet.
Welcome to the beginning of the small satellite revolution.
And when you think about this market as a whole, considering Gilmour Space was initially bootstrapped by Adam Gilmour and last year raised a Series A round of just $5 million, the company has achieved an extraordinary amount. So where are you in your sort of like timeline of what you're hoping to achieve?
Yeah, we're about halfway. So we think we're going to do our first orbital shots in early 2020 and commercial shots by the end of 2020. So we're about 2.5 years behind Rocket Lab. One of the things that's great about the launch market is the amount of satellites that need to be launched is in the thousands in the next 5 years. And, you know, I consider there's about 4 or 5 small rocket companies in development, including Rocket Lab, that will probably make it to be successful in orbital rockets. Even if all of us get there, there's still not enough of our rockets to launch all the satellites. So I'm not really worried too much about the competition right now because we could all be successful and get enough business. Same kind of concept with 50 different airliners. You know, there's a lot of airliners out there. They're all, you know, making money, getting customers. It's the same with rockets, especially small rockets, because the satellite market is so big.
Gilmour Space has around 30 employees and plans to launch a test rocket this year, which will reach heights of around 70 kilometres. And that small satellite market Adam mentioned was valued at $1.92 billion in 2015. And it's set to grow to $4.47 billion by 2020.
But Adam isn't your ordinary space entrepreneur. He actually started his career in banking before deciding that he wanted to get in on the space race. And it's this background in finance which Adam says gives him a unique advantage when it comes to building low-cost rockets.
One of the things bankers do a lot is they look at what industries are growing, what are falling, and what industries are ripe for kind of rapid change. And I looked at space as an industry that was ready for rapid change. You know, it had been this kind of old industry that hadn't changed much since the 1950s. And I thought this was something that could be changed dramatically. The prices were just far too expensive. I saw the billionaires coming into the business, and that gave me a lot of kind of confidence because these guys don't muck around.
Now, one of the ways that Gilmour Space is trying to do space on the cheap is to harness 3D printing. A lot of their rocket parts are printed, and they've also developed a way to 3D print part of the rocket's fuel source.
We've got a type of rocket called a hybrid rocket engine, and that is an engine that uses a liquid oxidizer and a solid fuel. The technology around that's been around since the 1950s, but it's never aggressively been gone after for kind of big commercial rockets because there's been problems with hybrids in the past. We did a lot of research on why those problems happen and thought we could fix them, that we knew a way.
What sort of problems are you talking about?
In a nutshell, they either burn too fast or burn too slow, the actual fuel. So we kind of went like a little bit like Goldilocks and found a fuel that burns just right. And we've been testing that fuel for the last 18 months in different engine sizes, all the way up to, in December, we tested a really big motor that we'll use for our orbital vehicle, generated, double the thrust of, say, Rocket Lab's motor, even under half pressure. We got another test in about a week and a half at full pressure where we'll be like 4 times as powerful as Rocket Lab's motor. So we basically already proved our methodology on this hybrid fuel works, and that's probably the largest technological risk the company has that we're taking off the table now. After here, it's basically stuff like stage separation, guidance, navigation and control, payload fairing separation. All of these technologies have been around for a long time, and on a lot of them we're actually talking to other space industry players who are trying to get into the small market and offering very, very good prices for some of these critical components. Prices that are so good, it's cheaper for us to buy it from them than develop it ourselves.
Many people will remember the SpaceX rocket, which exploded on the launch site in September 2016. It was a couple of days out from launch and was carrying a satellite that Facebook was planning to use as part of its quest to deliver free internet across the globe.
These catastrophic failures are often caused by very small problems, and SpaceX have said the failure was likely due to a small buildup of liquid oxygen in a buckle in the lining of one of their fuel tanks. But Gilmour Space is using a hybrid rocket system, and Adam says one of the advantages of using this method is safety. The fuel is kept in both liquid and solid forms, making it unlikely they would have a failure in one of their engines.
That's the beauty of our motor system. We cannot have a catastrophic explosion in our rocket motor. We just can't. So, and that's basically chemistry.
Then why don't they build rockets the same way that you're building them?
Well, because I think, people thought hybrids just didn't work. They just thought, okay, they had limited opportunities, limited capability, and we figured out a way to get them to work. So I think what my wife worries about is that after we've successfully proved hybrid rockets work, other people will start having a better look at them.
But having a fuel system that's more stable doesn't mean the development process is completely problem-free. Almost every rocket company runs into some technical glitches. SpaceX famously released a blooper reel of all their rocket explosions, and Gilmour Space has certainly had their fair share of issues during the testing process.
We've had a couple of small detonations, mainly on just pressure vessels that went beyond their operating pressure and then had the end cap flew off, but small stuff, like 10-litre tanks and stuff like that. And since then, we're a lot more careful with pressure vessels, and we hydrostatically test everything now, which means you kind of put water in it and then pressurize it. And then if you have a leak, if it's going to burst, it just leaks. So you get a water leak first. So it's a really safe way of pressure testing pressure vessels. So we haven't had anything go wrong in the last 18 months.
And we'll have more with Adam Gilmour right after this break. Now, before the break, we were speaking with Adam Gilmour, the founder of Gilmour Space Technologies, a startup that's trying to get in on the new space market by building low-cost rockets to deliver small satellites to orbit. Adam showed me around his warehouse on the Gold Coast, and it's amazing to see how his team are actually making their rocket a reality.
So this is one of the nozzles that we made. So we make this nozzle out of a carbon fibre composite, and we have a mould in the nozzle design, and then we wrap it around. So up here we've got some aluminium tanks that we're using for some of our early vehicles to use as oxidizer tanks and for the fuel grain tank. We're moving off of this as a technology. After this, we're going to all carbon fibre, because these even though they're lightweight aluminium alloys that are aerospace grade, they're still a lot heavier than carbon fibre. They're fine for sounding rockets, but not good for orbital.
Is carbon fibre still cheap at the scale to?
Yeah, it's one of those. The material's actually pretty cheap, but to manufacture it can be expensive. So we're buying a machine that can manufacture it ourselves. Inside of there, they're actually making the fuel for the next big engine that we're going to test next week.
Is it like a complex process to make the fuel?
Yeah, it is. You've got to be reasonably precise, and we're mixing different stuff, and we use that as part of the 3D printing process as well.
Now, all of these components are designed to be cheap to mass produce and eventually thrown away after a single usage. Unlike companies like SpaceX, who are actively pursuing the idea of reusable rockets in an effort to reduce their costs, Gilmour Space is hoping they can make the entire process cheap enough that you don't need to worry about making the rockets reusable.
Reusability is another kind of buzzword that's out there, but we're still waiting to see what the true cost of reusability is, because people like to think that it's going to be like a jet where you can kind of land the jet, put some fuel in it and take it off again, but they forget that jets actually have a lot of maintenance on them as well. You know, about a third of an airline's operating cost is its maintenance on its aircraft. So it's not like you can land a rocket and refuel it for free and take it up and there's no other costs. If you look at what SpaceX has done, I think the quickest he's turned around a rocket is around about 6 months. So for 6 months, he's had people working on that and spending money refurbishing it. His goal is to get it to a day. If he does that, it probably will become quite economical, but let's see if he can. Otherwise, it's a lot cheaper to just mass produce a whole lot.
When you think about the space race, you probably think about the two biggest competitors, the United States and Russia, and before that, the Soviet Union. But many other countries are now catching up with their own space programs. Gilmour Space is hoping to base their rocket manufacturing in Australia, and with good timing as Australia prepares to launch its own national space agency. And one of the advantages of being located in the Southern Hemisphere is the conditions for launch. You've got low air traffic, and Australia in particular has plenty of open space for launches. Over in New Zealand, Rocket Lab already has approval to launch up to 120 times per year, and Gilmour is hoping the Australian government can get a launch facility built before they need to look elsewhere.
We'd get a lot further if we just move straight to the US. You know, there's so much better infrastructure there. There's so much better investor appetite. So I think we're at a disadvantage here. We don't really have any government support. We haven't had any big grants from the government, a small one from the Queensland government. That's about it. You look at them in America, NASA's funding so many different companies with big bucks to develop technology. So, we'd be in an advantage if we moved. And we may move. We can build fighter jets, and we can build rockets, and we can build whatever we want. It's just you've got to believe that you can. And that's what everybody else does.
Now, Adam isn't holding out hope for a launch site to be built locally, so they've been talking to NASA about launching their rockets from the Kennedy Space Center in Florida. NASA has been preparing for small launch vehicles and are providing an attractive pricing structure. And every dollar matters if you're a small startup trying to do space on the cheap, because every cent spent on launching the rocket will go on the bottom line. So I asked Adam about what those costs will actually look like to a customer.
I'm a satellite provider, and I have a satellite. I want to put it in space, and I come to you and I say, I want you to put my satellite in space. How much does it cost?
Well, we're selling the whole vehicle for around $8 million. And we've got prices on our website that range from about $32,000 a kilo for small stuff down to $21,000 a kilo for big stuff. $21,000 is the cheapest in the market.
And that compares to, I think, SpaceX have like 60 to 90 million for a launch.
Yeah, so price per kilogram of the big rockets is way cheap. It's like $3,000 a kilo. But to get that price, you have to put a bus on SpaceX, right? So if you want to put a small rocket on SpaceX, they'll charge you $50,000 a kilo. Well, they won't even do it. A provider will congregate a whole lot of small sats, put it on a SpaceX rocket, and take it up. But they charge around $50,000 to $70,000 a kilo. So we're going to be significantly cheaper than that.
When did you first become interested in space? Like, do you remember the moment when you first, got a feeling that space was something that fascinated you?
No, I don't really remember the exact moment, but I remember when I was 4, my parents went to the US and told me they were going to Kennedy Space Center. And I remember asking my dad to bring me back a rocket. And I meant a real one, but he got me back a toy one. And I remember when he came and gave me the toy rocket, it was a Saturn V, very proudly. And I looked at it and I'm like, that's not big enough. I want a big one.
Do you want to go to Mars?
Not really, no. I mean, I really like the Earth. I think it's fantastic. I'd love to go to space. If you look at the moon and Mars, right? The moon is a 3-day trip. You can spend 2 days there and be back within the week. Mars is 6 months there. Because of the way the planets align, you've got to spend another 1.5 years on the surface before you can even come back. It's a 2-year round trip. I just don't really want to be off the planet for 2 years.
If you look at your company in like 10 years, what does it look like? Is it just doing rockets, or, are you providing technology to other companies, or like what do you see yourself as in 10 years or 20 years?
We're working on an upper stage that can take a 20 kilogram package to the orbit of the moon or Mars, or even 10 kilograms to the orbit of Saturn. And that you can put, for 20 kilograms, you can put a pretty cool science satellite on that with great cameras, other sensors, solar panels, a radar dish. So we think we can do a lot of work on, solar system exploration on the real cheap. We've been talking to NASA about this already. So that's some of the coolest stuff we're going to do. 5 years away, 7 years away, is planetary exploration on the super cheap.
Despite the huge interest in new space companies wanting to get out there and explore, space is known to be an expensive business, which you can only break into with enough capital. But when you're building a space company in a market like Australia, convincing investors of the benefits of building a rocket can be challenging.
We've had to educate investors just on the industry itself. What is the opportunity? I guess the best investors that we've found have already invested in a satellite company. So they understand the profitability of the satellite companies, and then we're a derivative of that because we have to launch the satellite companies. But if you find an investor that just doesn't know anything about space, it's very hard to convince them about space.
What are usually the questions that they have?
How are you going to make money? Well, how does anybody make money in space? They don't understand space as a $350 billion global industry annually. And a lot of people just don't realize how much money's in space. They don't realize how much everybody uses space. On your phone is space technology. If you use Google Maps, space technology. When you take money out of an ATM, space technology. Space technology is everywhere, and you're paying for it, even if you don't think you are. But people don't realize that, right? And the only way anything gets into space is when a rocket sends it.
And that'll be you.
We'll be one of them, yeah.
Thanks for joining us on another episode of Moonshot as we explore the future that's about to happen. If you want to find out more about the show, head across to our website, moonshot.audio, or follow us on Facebook, Twitter, and Instagram. Just search for Moonshot Pod. Our cover artwork is by Andrew Millist, and our theme music is by Breakmaster Cylinder. Moonshot is a production of Lawson Media, and it's hosted by me, Christopher Lawson, and also Andrew Moon. Join us again next time as we explore more ideas that are set to change our future. Coming up in the next episode of Moonshot.
We are used to launch satellites, and they are up there for 50 years. So we use technology of 50 years ago. These little guys, we can update them maybe 3 years. It's really like an iPhone.